Hello everyone. I was told by my physics teacher to walk through his 9 physics word problems that he's given me and my classmates in his period. So before I start, I would like to apologize if I was incorrect or later on in the video, and I'll put on captions to correct myself on what I said wrong. So let's get started. Okay. For the first question, how much does the electric charge passes through a cross-sectional area of the wire of the current flow of 0.5 milliamperes in 10 minutes? So for this question, we're going to use the formula to find the charge, which is charge equals current multiplied by time. For time, we're going to use seconds. So, first we're going to locate the current. The question has given us 0.5 milliamperes. But we're going to change it to a number form, which is... Oh, focus please. Focus please. There we go. 0.5 multiplied by 10 in the power of -3. And for seconds, we're going to change minutes to seconds. So we're going to multiply 10 with 60, because 1 minute equals 60 seconds. So we have 600 seconds in total. Now we've located the the current and the time. We're going to do the math. So charge equals 0.5 multiplied by 10 to the power -3, and multiply again with 600. When you do the math, it equals 0.3 coulombs, or C for short. Now for the second question, what is the current in the circuit that's 6 microcoulombs of an electrical charge flows through a conductive wire in 5 minutes? For this question, we're going to use the formula I equals Q divided by T, or current equals charge divided by time. We already know that the time is 5 minutes, but we're going to use seconds, so we're going to multiply 5 with 60, so it's 300 seconds. While the charge is 6 microcoulombs. Microcoulombs, when we're going to change to a number form, is 6 multiplied by 10 in the power of -6. Now we already found the seconds, the time, and the charge, so we're going to do the math. Current equals 6 multiplied by 10 in the power of -6 and divided by 300. When we're finished, the total current is 2 multiplied by 10 in the power of -8. Next up, a metal wire with a cross-sectional area of 0.04 centimeters squared is 6 centimeters long. If the resistivity of a wire is 8 multiplied by 10 to the power of -7 ohms, determine the resistance. For this, we're going to use the formula of resistance, which is... I can't remember what this is, so I'm going to use note for now. I'll put on captions on what it means, and we're going to multiply by length and divide it by the cross-sectional area. The cross-sectional area is 0.04 centimeters squared, so we already know what it is. And for the length is 6 centimeters long. And the resistivity is 8 multiplied by 10 to the power of -7. So, 8 to the power of -7, then multiply again with 6 and divide it by 0.04 the power of negative 2. For y, it's power of negative 2 because we want to change 0.04 into just 4. We're going to change it to not let it be a decimal. And when we do the maths, resistance equals 3 over 250, or in the decimal form is 0.012. Okay, for question 4, wire A and B are made of different materials. The ratio of resistivity A to B is 4 to 5, length A to B is 15 to 2, and diameter A to B is 4 to 3. Determine the ratio of resistance A to B. So for this the formula for this question is actually really simple than you think it is. So basically the resistance of A divided by the resistance of B. So it's node A divided by node B and multiply by length of A divided by length of B, then multiply again with the cross-sectional area of B and the cross-sectional area of A, and power of 2 squared. So for this, we already located that the resistance is 4 to 5, length is 15 to 2, and the diameter is 4 to 3. So I'm going to change it to a fractional form. So A or E 4 to 5 multiply 15 to 2 and multiply by 3 over 4 squared. And you can cancel a lot of numbers in here and you will get A to B equals 9 over 2, or 9 to 2. For number 5, a light bulb with resistance of 100 ohms is connected to a potential difference of 300 volts. Determine the current flows through the light bulb. For this question, we're going to use the formula of finding the current, which is current equals volts divided by the resistance. We already know that the volts is 300. So current equals 300, and we're going to divide it by 100 ohms, which is the resistance. We cancel the zeros and we got 3 amperes of the current. For number 6, if a current flows through a light bulb, which is 7 amperes, and the voltmeter crosses the light bulb reads as 1200 volts. Determine the resistance of the bulb. For number 6, it also kind of uses the same formula as number 5. We need to find the resistance for the resistance, but for number 5 we only use to find the current. If we're going to find resistance equals volts divided by the current. We already know that the current is 7 amperes, while the volt equals 2100 volts. We're going to do the maths. Resistance equals 2100 volts divided by 7. We're going to cancel, and it's 300 ohms. As you can see. Number 7, a current of 30 milliamperes flows through a light bulb with a resistance of 12 ohms. Determine the potential difference across the light bulb. For the potential difference, or volts, we're going to use the formula volts equals current multiply with the resistance. So volts equals 30 multiplied by 10 to the power -3, because we're going to change 30 milliamperes to a number form, which milli is 10 in the power of -3. And we're going to multiply it by 12 ohms, which is the resistance. Do the maths, and we got 0.36 volts in total. Okay, for number 8, it looks complicated. This is actually the question here. We're going to find out how much of the ohms are used in this circuit. This is called the mixed connection. It mixes with a lot of connections. So we're going to do the first row of the row here. Row here first. So I'm going to call this A. For row A equals, the formula is always 2 of the ohms multiplied together divided by the sum of the ohms together. So it's 600 multiplied by 400, then divided by the sum, which is 1000. And when we cancel the numbers, we got 240 ohms. But we're going to use the ohms here, and we're going to calculate row here. This specific row. I'm going to call it row B. Row B equals 60. Then we're going to add it with the ohm that we got from the first one, which is 240 equals 300. For number 8, the question is this. This is called the mixed connection. It's a type of connecting resistors, and for this question, we're going to calculate the total ohms that it's used in this mixed connection. So first, we're going to calculate the first row, which the rows is over here and here. Alright, this is not focused. Please focus. Focus, thank you. So I'm gonna call this row here in total is row A. For row A, the formula is always the product of the 2 ohms divided by the total sum of the 2 ohms. So it's 600 multiplied by 400 divided by 1000. And we can cancel these numbers here, and when you do the math, it's 240 ohms. Please focus, please. Go on, focus. The phone does not focus at all. Okay, thank you. So we got the 240 ohms here, right? We're going to later use this in the next row, which is the row here in total. So I'm going to call this row B. For row B, you only need to add up, because this row here equals the total of one row, and we're going to take 60 ohms. Then we're going to add it with 240 ohms, which is 300 ohms. So I already calculated that the ohms, the row here in total is 300. So for row, I'm going to calculate row here, row A, not row A, row big A and row big B. We're going to add it up, and then as the same formula as for row little a, we're going to have the product of the 2 ohms, then divided by the sum of the 2 ohms. So row big A, 300 multiplied by 100 divided by 400. Cancel the numbers and do the math. Equals 75 ohms in total. So we can manage to calculate all of the rows here. Then we're going to add it with 250 ohms from the start. So the total rows for this mixed connection is 75 and added with 250 equals 325 ohms in total. Camera, please focus. For the last question, this is called series, where you have the series of rows here. It's not like the question 8. It's actually a mixed connection because you mix connection within a connection. So for the first question, it asks to determine the total resistance. For this question, we're going to use the formula of finding the resistance in each row, which the total resistance equals row 1 added with row 2 and row 3. And as you can see, are given the total resistance or ohms. We're going to change it into a fraction, which is 1 over 10 plus 1 over 2 and plus 1 over 1. And then for in total, we got, let's see here, we got 23 over 20 k ohms in total for number 1. As for number 2, determine the current flow through row 3. So for this question, I'm going to use the total current, the formula. The current equals volts divided by resistance, which the volts is actually here, 9 volts, and the resistance is 1k over 1000. So the current equals 9 over 100, 1000. And we can't really cancel, so that is the current flow through row 3. And that's all the questions, and I hope I correct myself when I'm editing this video, and thank you for watching. Bye bye.